Okay, let's go ahead and get started. I'd like to thank everybody for joining us today. Welcome to today's webinar, Pivoting Your Pipeline for Microservices. I'm Julius Rosenthal. I'll be moderating today's webinar. We would like to thank our presenters today, Nathan Martin, CEO at Sagecore Technologies, and Tracy Ragan, CEO at DeployHub. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end of the presentation. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all of your fellow participants and presenters. Please note that the recording and slides will be available later today on the CNCF webinar page. With that, I'll hand it over to Nathan and Tracy to kick off today's presentation.
Thank you so much, and I want to thank the CNCF for hosting this webinar and having us present. This is a fun topic for me. I have been doing, I guess what you'd call the software delivery lifecycle for pretty much most of my career. And I'm part of the CD Foundation. I'm on the CD Foundation board, which is a sister organization to the CNCF. If you don't know about it, go learn about the CD Foundation. We're doing some interesting things there around continuous delivery. I was also on the founding board of the Eclipse Foundation. I'm a DevOps Institute ambassador, and I love to talk about microservices. Nathan's going to take the second half of this presentation because he's going to dig down into some stuff that he's doing around Istio. But I want to say he's one of those customers that you love to geek out with. So thank you, Nate, for agreeing to be on this and showing what you're doing at Sagecore.
Absolutely.
So just to get started here, what we're going to cover, they tell you just to, tell your audience what you're going to tell them. You tell them, and then you tell them what you told them. We're going to do it that way because there's a lot of information, and this stuff can be really confusing. So we're going to cover a cloud native journey in what is now called a CD pipeline. Kubernetes and microservices is really moving us away from this monolithic style of software development to a service-based approach. And that really will require that you pivot your pipeline. There are going to be some problem areas that we're going to cover so that you can at least start thinking about it. We're also going to take a look at a use case where Istio is brought into the broader picture to do some routing. And it may not seem, intuitive that Istio would be part of your CI/CD pipeline, but because Istio does the routing, it does become part of your pipeline. So that's what I mean. Well, there's a lot to learn about how the pipeline's pivoting, and I'm hoping that this presentation will get you thinking about what you need to do for the future. So again, things to think about. Most organizations, when you're working in a microservice world, you're going to probably within your CD pipeline have every workflow will represent one microservice. So you have a microservice will be related to a repository, and that repository is going to be related to a workflow, which means you're going to need lots of workflows running, and we're going to need to talk about templates. Configuration management is going to be lost, and we're going to talk a little bit about that, and it's lost mainly because we don't do builds anymore. And then the way we deploy software is going to be different. And Service Mesh comes into that picture. Service Mesh has the potential of finally getting rid of a waterfall approach where you don't necessarily have dev environments, test environments, and production environments. Now, I know that sounds crazy, but it's true. And I know that most of you, even if you're working in Kubernetes, you probably have clusters, mini clusters. I've had some customers we talked to, one of them recently said they had over 70 clusters. So we know that you have a lot of clusters now, but Service Mesh has the ability to help you reduce the number of clusters you have to manage. So let's just go quickly over what functions are. And I know this is a CNCF group, so you should really know what functions are. But I mean, microservices are functions. You have to think functions when you think microservices. So the key to really understanding how microservices can be leveraged is to really think about them in terms of functions. And microservices are immutable. Now, this is going to be an interesting fact when we get later and talk about Istio, but think about the fact that you can push a microservice to your cluster, and that particular version could go on living as well as a new one living right next to it, which means that you could have applications connecting to both microservices. I know that's not what we are used to in monolithic, because in monolithic, you take your binary, you compile it, and you push it out, and you push it into certain areas, and it's copied over. It's not immutable. So what you need to think about in terms of what your journey, especially on the CD front, is that you're taking your application and you're taking a hammer to it and you're breaking it into lots of little pieces, like lots of little pieces potentially. Netflix has somewhere in the ballpark of 4,500 microservices that they're managing. So it's like taking a wine glass and taking a hammer to it, and now you have a pile of glass that you call your application. The application is still there, it's just lost, but it's still there and we still need to represent it. And it's still what your end users are executing, right? They're not running a microservice, they're running a version of your application. So with microservices, your overall landscape begins to change. When you shift to a modern architecture, you have to think about how you're going to manage individual microservices that are deployed independently. Now, while we talk a lot about managing the Kubernetes environment, and I know a lot of money, investment, and time has gone into managing at that level, what we're really talking about today is the CD pipeline as it relates to managing the applications that you're building in your microservices environment. What's running on those clusters, not necessarily how to orchestrate or manage those clusters, but what's running on them and how are your customers executing what you're putting out there. And why is the CD pipeline disrupted? What is it about microservices that changes the way we manage a CD process? Isn't there still a build, test, and a release? Microservices, because they're deployed independently, it kind of changes everything we do. It really disrupts our basic understanding about how a CD process operates. And your dev, test, and prod environments are morphing, seriously morphing. And Nate's going to talk a lot about how they're morphing and how Istio allows them to morph. So let's just think, we have to, in order to understand the problem, sometimes it's easier to look at our history. And if we look at how builds are put together in the monolithic world, what we do today in monolithic is we have a build meister who pretty much focuses entire day on making sure that your CD pipeline, when you do a check-in, that your code compiles. And what that means is they make decisions about what code needs to be checked out for that compile, what versions of the code. They also determine what versions of libraries may be used. They may use something like an Artifactory or Maven to try to look at transient dependencies. But the point is they make some really important decisions about pulling together what your binary looks like. Now, when we did the linking there, we did it really early, right? It's the first step in our CD pipeline. In a microservice environment, we do it last. So we go from linking a dev at the very first part of our CD pipeline to managing that linkage through APIs and in a runtime environment. And that runtime environment can be very different. You can have many clusters that you're doing the linking at every cluster that you deploy to. And every cluster you deploy to, because that could have a different configuration of microservices. So our builds will shift. You'll still have a CI process, but your compile, if you do compile, will be small. If you're using something like Golang, you may compile. But if you're using Python, you're not. But you are creating a build image, and you're registering a build image. And that's what our new build will look like. Workflows, I think, will cause most people moving into this new area the biggest problem. In terms of how your pipeline needs to shift to support this new model, we have to think in terms of having a single microservice that is independently deployed, so it needs its own workflow. while most of you are probably using, you have some very nice CI/CD pipelines, you're probably going to have to look at restructuring them in some way, because what you need is to be able to have a templated design. You know, I just learned about Jenkins X not too long ago. I started putting my head into it. And while a containerized pipeline solves some problems just for your pipeline in terms of plugins and encapsulating those so a new plugin doesn't break everybody else, that level of that change in thinking about putting containerizing your pipelines means that you could actually template based on those containers. So think about, as you move forward, how you're going to manage hundreds of workflows and potentially want to make a change in a single workflow that will replicate down or will be automatically seen by other workflows. Because what you don't want is to be managing 1,000 workflows. Now, in terms of the three core, or let's just say the two for today, the two core pieces of a CI pipeline, a CD pipeline, is build and release. And those are the two pieces that are going to be impacted the most. When you have workflows running through separate microservices running through these separate workflows, and you're pushing them out independently, you really begin to understand the loss of the application version in view. This is a configuration management issue that was resolved when you did the build in monolithic and you made those decisions. You created a build number, you had an application version number that you were running off of. All of that goes away. So while you have all of these workflows running, you're going to need to start aggregating them back down to what it is that they're pushing out. And keep in mind that microservices in a really proper implementation are reusable, which means one API developer could update a microservice, get it pushed out to the cluster, and you as an application team now has a new version of the application. Again, we're talking about basic configuration management problems that the microservice environment creates that we have to start thinking about solving in the CD pipeline. So I love to call these images Death Stars because that's what they very much look like. And I saw somebody reference that on a Google post somewhere along the line a couple of years ago, and I've used it. Again, Netflix alone has about 4,500 microservices. You know, thank goodness they have microservices, because I know we all want to watch the 5th season of The Last Kingdom as soon as it comes out. If you haven't watched 1 through 4, you better start because it's really good. But thank goodness that they can support the kind of usage, and they can support that kind of usage because they are built around a microservice environment, allowing these things to spin up and spin down on as they need to. But that doesn't mean it comes without some issues, and configuration management is one of those issues. I'm hearing new terms like haunted graveyards and Frankenstein clusters, questions about when do you deprecate a microservice. A haunted graveyard, meaning that you might have a node out there that's running a bunch of containers, and yet or a container that you have no idea what it does, but it has transactions going to it. So if you take it away, somebody's going to haunt you. Frankenstein clusters are just kind of grow and get bigger and bigger, but you really don't have a good understanding. There's observability tools that are working to help us find this kind of data based on the running of it in a cluster. But we have to think about how we solve that problem in the monolithic. We did it at the build, and we had a lot of control about what went into a particular binary. We need to recognize that that is what we need to bring back into the CD pipeline in order to have visibility of the application level, regardless of the cluster that it's running in. So it's a versioning issue. The other thing you're going to see, and this is an amazing topic if you're moving into microservices, and I highly recommend you read about it and learn as much as you can. And that is adding a domain-driven design into this entire process, which means that instead of having a kitchen drawer full of microservices that you just throw in there and it's this junk drawer, everybody has a kitchen junk drawer, you know, where's the reading glasses, you dig through it. That is not what you want to do with microservices. Every microservice needs to have its own drawer, so you know where to go find one if you're looking for it. If you're writing a really good security services, single sign-on, you want to make, and you're sitting on the 8th floor, you want to make sure that the teams on the 4th floor know where that is. A domain-driven design helps you do that. It is what creates a platform for defining the patterns within your organization. And your patterns are going to determine what kind of microservices that you need to develop and where the value is in those microservices. So understanding how to start building out domains and how those domains relate to each other will trickle down and allow you to be able to start understanding how you decompose your application. And in some cases, you might start by decomposing your applications and understand those patterns and see if you can start defining those domain structures, you know, database access routines, centralized logging, security routines, logon. There are ways that you can start seeing patterns even by decomposing one application. When you get to the second one, those patterns really start showing themselves, and that's how you begin building a domain-driven design. And that domain-driven design needs to be part of what you're doing in terms of understanding where the pieces and parts come from, what the versions are, and where do we go if we need to understand if this domain still has value. So we're going to go through a few things that's kind of changing. I think Helm is certainly become everybody's favorite for creating your new containers and applying those containers to the cluster. So if you haven't looked at Helm, you should be taking a close look at Helm because it probably will become one of the core pieces of your CD pipeline. Ortelius is a open source project near and dear to my heart. DeployHub is one of the main contributors. We're working with companies to help them catalog and organize microservices and track the visualization of those applications. Istio is what we're really going to focus on today. And Istio makes for an interesting part of the CD pipeline because it really is going to change the way we think about doing releases. And that's why it's important. Remember, the two main functions of your CD pipeline, build and release. I mean, there's other things in there, security scanning and testing. And I mean, there's certainly other parts of the ecosystem. But why we did this in the first place was to be able to compile on a check-in and get it out to the customers as quickly as possible. Those two key components are morphing. And Istio is one of the reasons why. So let's just think about what that CD pipeline might look like in the future. Your build is going to switch from building binaries to creating container images. You're going to have a way to track what microservices and how they're being executed, not just in one cluster, but across many clusters. It's a typical configuration management release kind of problem set that we need to solve. Helm will be helping us with creating those container images and pushing those images out to the clusters. And then we're going to talk about service mesh and the ability to route. And then that brings us back through the feedback loop to creating the understanding where problems are and then where we need to start them again. So kind of if we go over this, you're going to have container images instead of compiles. Your BOM report's going to have, and your diff report's going to have to come from some other place. And that's tools like DeployHub and Ortelius that's doing configuration management. Helm is going to be the piece that pushes your container out to your cluster. It does it so easily. You don't need a big heavy ARA tool to do that, to be quite honest. And when it comes to where it's going and how it's being routed, Istio becomes that piece. So the results are going to be, you're going to get rid of these monolithic compile scripts. Everybody will be able to do a 10-minute build. It will finally happen. Configuration management, however, is going to become more critical because we lose the BOM reports and the diff reports and the impact analysis when we threw away the build. The CD pipeline needs to be able to support literally hundreds of workflows. So looking at tools that provide a good templating service for the workflows, or even ones that are going to be event-driven. Tekton is part of the Google Kubernetes core, and it is based on CRDs. So you can execute a CRD to do events that the pipeline would have normally pushed. And then routing and feedback is going to come from Istio. So if you think about it, this is my last slide, and I'm going to pass it over to Nate, who's really going to dive down into how he implemented Istio. Istio can perform user routing, and right now we are working with Sagecore to beta test this out. But what it has the ability to do is to be the central point to pass off a change in a microservice. So let's say we push email service v1.7 out to the cluster. Istio has the potential of saying, hey, you're a developer. When you execute this application, you need to execute the new version of the application, which uses this new version of the email service. Now that's different from installing it into a development cluster and then saying, let's execute the new microservice in the dev cluster. It means that it's going to be using all of the other stuff from the production level. And when it comes to a release, it's just routing again. Now, when I first realized that this was possible, I spoke to some people and they looked at me like I was green, seriously. They were like, you're insane. And then we did recently we did a meetup with a company out of Santa Fe called Descartes Labs, and they're a big Spinnaker user. And he had a pretty detailed presentation around Spinnaker. And then towards the end of the meeting, end of the session, he said, now I'm going to tell you guys something and you're going to think I'm crazy, but we have gotten rid of all of our dev test environments. And now we just have a dev test cluster. We have a dev test cluster, and then we have a production cluster. We put everything we do for dev and test is in a single cluster. And they did that because they had such a bad cluster sprawl problem. They needed to figure out a better way to do it. And when they put their heads together, some really sharp guys from Los Alamos, they really realized that that was the best way to do it. And on that, I am going to pass it over to Nate, who's going to go through a real-world use case in using Istio in this way.
Thank you, Tracy. Well, thank you everyone for being here today. I'm going to dive into some of the things like Tracy said about, really some of the challenges that we had as a company, what our software is that led to these challenges ultimately, and how we solved those, and some good examples that will help you to think about your architecture moving forward, because sometimes knowing these examples will help you to work on your domain-driven design, your routing, your dev test cluster, all that kind of stuff. So we started a couple years ago in the true dynamic enterprise resource planning realm. What I mean by that is traditionally, the last 8 years, Sagecore Technologies has been custom developing enterprise software to essentially manage, track, and report on data for various organizations, right? Now, we started developing Tetracore to help us solve the problem of scalability within that sector. And ultimately, we decided to move to a managed GKE, or a managed Kubernetes platform. Obviously, GKE is our choice, with Istio as the service mesh for the routing. So our main challenges really came down to the deployment staging. So being able to see a microservice, being able to test on it in a very specific context, and then release it to then another specific context. Same thing with versioning. If you deploy a microservice that you need to change, you have to be able to version that appropriately. We'll dive more into that. Our request routing, being able to actually route to a specific microservice for a particular context. I'm going to use context a lot in my slides, only because in the dynamic enterprise realm, everything is context. There's nothing really set in stone. So hopefully I don't confuse people with this. So our host-based routing is really a good example of the domain-driven design that Tracy got into earlier. So in this example, we're routing all traffic from myapp.com, which is default to production. And then we also have prod.myapp.com, which is our direct production route. Both of them are going to route to the same spot. However, in the future, I could choose to split those if I wanted to. In this YAML, you'll see that they're both routing to my production version, and we'll get into a little bit of how that's actually delegated here in a couple of slides. So what we realized here was that, while yes, we can do some host-based routing within the Kubernetes ingress objects and whatnot. However, there were some limitations when we actually used that in production. We also really needed a much more dynamic lifecycle to actually test each service, to test the routing on different domains, given that our solutions really, there's not a lockdown in domains. So we actually have to be very, very, very structured with our domain-driven design. And we also need to actually automate our CD pipeline so that when we roll out or when we push a new image, that it's very easy for us to actually put it into the right spot, to deploy it into our cluster and route it accordingly without tons of heartache, right, and work. So we'll dive into how we do that next. So one of the things that we do for the routing of different destinations, so different microservice versions, I should say, is by setting up the Istio destination rules. So this really, for us, has been able to make host-driven deployments much simpler and much quicker than the Kubernetes ingress. So what really makes this different? Obviously I can update my Kubernetes ingress object. You'll see that your routing will update, accordingly, and everything's fine. The problem is usually especially in a managed scenario, like GKE or AWS, you're going to have a lag time, right? While they're setting up all the abstractions to their routing rules, all that stuff. It takes, on GKE, you're talking a couple minutes, right? That can be a problem when you're talking a massive organization, for example, that we might be serving. A couple minutes can be the difference between, I almost want to say life or death. We're talking big data. Anything can happen when you're processing huge amounts of data. So you have to have that ability to update things instantly, be able to rectify things instantly, whether it's in your routing on the host level, on the path level, etc. And for us, Istio really solved this problem nicely. We've looked into some of the other service meshes, and I won't talk to the validity of them. I'm sure they're all great, but Istio seemed to be the easiest to implement within the Kubernetes environment, quite frankly. So that's why we chose that. Let's move on here. So another problem that we really had, especially in our case, was that our request routing is not just static. So obviously, we're using a whole different combination of host and path-based routing, cookie routing, etc. But we really needed that core fundamental architecture to be able to actually define these things once across multiple clusters, and then all of those routes persist, right? That way it's more of an issue of versioning than it is of, am I actually routing to the right application or microservice, I should say, within my application. So this, you can hit a limit quite quickly on the Kubernetes ingress routing, and that's really the biggest limit that I think we saw. It's great for your top level network design, very, very top level, but I think there's always a limit. I think it's up to like 13 rules in GKE, but I won't speak to that. Let's see, what's next here? Okay, so like I said before, we're combining different methods of routing, headers, domain-based, cookie-based, even custom headers to help us do different things with different entry points, we'll say. And then our path-based routing, different essentially URLs within a domain. Without Istio, we really didn't have much of a way to actually connect these things in a way that will scale across, the US or even across the world. And better yet, not have to have tons and tons of developers to try to organize this stuff. So I'll walk through a couple examples of these routings. This is meant to be a broad scope YAML example. So obviously there's going to be some things you'll have to look into documentation yourself. These aren't necessarily full examples, but they do highlight the core components of, how the routing is being defined. So in this example, you can see here that we've defined our hosts, beta.myapp.com, very similar to the one that we defined for production. However, in this one, we're now routing to the destination of beta, which is still my app, but it's another version, right? So this might be, for testing your beta, right? Obviously. Let's move on here. So in your CD production, your CD process, right? We've talked about having the different labels to track your various releases, right? Obviously, none of these things, when you release something, they don't overwrite an old version. However, there is a human need for labeling a deployment or a version in a sense of which version in human terms am I working off? Because, in monolithic, right, we're all used to having a version number that we're working on for a period of time. And, at some point we all start working on the next version number. In this case, obviously it's not possible within Istio or within microservices inherently if you're, using it, because every deployment, every container that you build gets a unique version, right? So what we do here is we label the deployments based off of the Istio subsets. So you'll notice here that in these YAMLs, I've got two versions. One is my app version 2.1. The other is my app version 1. So on the very right, my deployment for production is version 1, and it's almost identical to alpha, or alpha to production, you get the point, except for the different version label. And so what this will do, if we move on to the next slide, this will correlate to something called a destination rule. So destination rule, in my mind, really, when I was learning this stuff, it kind of abstracts that problem that then we get with moving from monolithic thinking, is that, we're still working on a version. You don't want to have to increment by, a version every time you build a new image. It's very cumbersome to manage. So what we do here is, in our destination rule, we basically define a subset that will correlate to the version label that was in the previous slide. So the previous slide was your deployments, right? These destination rules label a human-friendly name to those version labels. So you'll see I put a production label to version 1. I've got a beta label for version 2.1 and an alpha for version 2.2. Now, let's move on to the next slide. Okay. So now what we can do is actually define virtual services to route to those appropriate subsets. So instead of saying that let's just take myapp.com, for example, instead of trying to route it every time to version 2.3, and then I update, release a new version, then I have to go and update every single virtual service to 2.3, or using this method, it would be simply defining that this host, myapp.com, is going to go to the subset called production, and then in our destination rules, we then define what production means in Istio terms, right? So now that changes our pipeline a little bit to for deployment. Let's go to the next slide, please. So in this case, obviously, we're showing beta is going to the beta subset. So this is another host-based routing example. And what we'll do here, let's show the next slide, please. So what we'll do in here is now actually update the destination role to change what version, right, will go to an actual subset. So in this case, you'll notice that version 1 is no longer the production version anymore. Now we've elevated version 2.1. That's now the most stable version. Everything's ready. We update our YAML file, push this out, and then now every single production routing will go to version 2.1. Another thing too that's really nice with this is, and we won't get into it, too much in this conversation, but being able to route 50% of your new traffic to production 2.1 or etc., right? But we'll save that for another time. Sorry. So the biggest challenge that we really had with migrating from monolithic, the mentality, right, is really being able to see what's happening. When you had a server, you could very easily go and look or even design the logs to essentially spit out exactly what you need to know about that function within your application. However, now our functions, everything's been exploded, and now we're actually talking about real microservices, all with their own different complexities and different environments that they may be running in, right? So how do we actually visualize what our cluster is doing, what Istio is routing to, and help us to solve problems that might come with converting from monolithic mentality into microservices? So one of the things here, and I'm sorry, Tracy, you might have to jump in on this one.
Yes, so the way for helping with this routing, what Ortelius, which is an open source project, does is helps with what Nate just described. It helps with the mapping of the services over to the clusters, basically. So it's doing the configuration management needed to update all of that that variable data that Nate was pointing out to, that tracks the routing and replaces what basically your deployment.
So it sounds like it makes it much easier for the end developer trying to come into this world of microservices, correct?
Yeah. Yeah. They don't have to go through everything that you just did.
Awesome. Well, so as far as visualization goes, and this is actually even more pertinent when you have a managed configuration, would be to see how everything's actually performing. So, which services are actually in this mesh? How are they connected? How are they performing? Are they healthy? Can I operate on them, or how can I operate on them, right? And being able to see that in an easy way that's not necessarily YAML files, right? So Kiali really solves this problem very well. And, there's some other tools out there that I urge you to look into, but Kiali really was the one that jumped out as far as visualization. Super simple. It's you can get the instructions to install it in your cluster on the Istio website as well as Kiali, but I believe Istio's documentation is going to be better in this context. So you can see here that we have a list of our microservices, and you can see that they're healthy. You can see the various labels that are attached to them. A lot of this stuff really would be managed by Ortelius, right? I would imagine, as far as the labels and whatnot goes. So that's another tool that would really help with this. So we've got our which microservices in the mesh. Now on the next slide here, we can see how they're performing in the sense of both health, both a namespace, which is actually a very, very, very big deal in Istio. Be very aware of your namespaces and how they relate. So this helps with that. And then next, how are they connected? So this actually solves problems for me all the time. You'd be surprised. Sometimes you may do a wildcard host or something that you might have done it twice on 2 different gateways in Istio or something. What will happen is then you'll be able to see exactly where the request is coming in, what microservice is routing to it, and a lot of times even if there's no possible destination for this request to go to. And Kiali does a very great UI for that. It basically will mark things red or alert you if there's something wrong. And a lot of times it's very easily fixed, but you have to be able to visualize it, right? And next. So
that's mine.
Yeah.
So thank you, Nate, very much for going through that. I think you gave a really great example of how you're using Istio to manage that routing. This is just a kind of a word from your sponsor. We do have Ortelius out there that's helping with the configuration management to be able to create those those destination rules that Nate covered. If you're interested, we would love to have you join the project and start talking about what that configuration management looks like and how to make those connections. Ortelius was the first map maker. So that's what Ortelius is doing, is we're building maps. And we see that as Nate pointed out, trying to adjust culturally from a microservice to a monolithic can be really challenging. This particular tool is helping solve that problem. So visit us on the Ortelius GitHub site. And there is our contact information for anybody you want. I'll leave that up. I'll leave this screen up here. So if you want to reach out to Nate, ask any questions about how he set up those destination rules, or if you want to reach out to me, that is how to do it. And on that, we will open it up for questions. And I'm going to bring up the Q&A here.
Great, thanks Tracy and Ragan. So first question, do Ortelius and Kiali, Istio solve the same types of problems, or are they different?
They're different. So Kiali is looking at what's occurring in the cluster on your behalf based on the routing that Istio did. Ortelius is happening before you ever get to the cluster. So it is the way you can manage your domains and structure your domain design. It allows your application teams to create what we call an application-based version, so that as the microservices change underneath it, you get a new version number associated to it, and it tracks what cluster it's being routed to. Once it's being routed, Kiali can help you understand what's actually occurring between your transactions. Great question, thank you. Whoever asked that. Any other questions?
I was wondering when that was.
Can you answer that one?
Yeah. So the question is, can Grafana be used? Yeah, so I had a feeling someone would ask this. Grafana is actually very popular, and yeah, it can be used. It actually, I believe, consumes the same data that, and I'll have to, anyway. But what it does though is, I think Grafana is a lot more metric based. So if you want to dive into certain things, based on labels or whatnot, I think that's more the, or having a dashboard that you'd view more often. I think that's when Grafana would be used more, but that's more personal preference than anything. I haven't seen though the kinds of relational microservice capability in Grafana yet that Kiali offers.
And I'm going to let you take the next one too, Nate. You're on a roll.
Sure. So question is, if people are able to consolidate dev/test and production clusters, how do they segregate data? I love this question. I'm going to try not to go too deep, but essentially it depends on your design. So if you have a single cluster and you're a I'll say a SaaS model that may, or let's say you're testing, or your data isn't actually sitting in the same microservice as your production microservice that would hold your data, whether that's a hosted MySQL or whatever that is. Separating the data out, but keeping the routing within a single cluster. That's the simplest answer I can provide there, without going too deep. If you want more on that, send me an email. I hope that's enough. And
I'll take this one. The question is, are there cases where Kiali and Ortelius are both used in the same cluster? So yeah, Ortelius does not run it all in a cluster. It is, again, sitting outside of the cluster, and it's looking at what's being pushed across all clusters. So you could look at Ortelius and say, I know what version of my application is running in any cluster. With Kiali, you would be running it at the cluster level, and you would be using it to visualize the routing and the transactions. So you would be running Kiali in multiple clusters, and Ortelius would be pushing the destination rules before it ever gets to the cluster. So it's doing the configuration management, and Kiali is watching what's actually occurring.
mm-hmm.
And I think we should get Nate to write a blog on the data question so he can dig into it. I'd love to hear a really complete answer about it. Because that is not the first time that question has come along.
And it's actually, we've gone through so many iterations ourselves to find the best production method. And a lot of it does come down to, what are you actually doing? What does your application do? How does it, work, all that. So yeah, I agree.
And there's this question, I don't think I can answer it. I know that everybody has a different journey when they're going through the migration over to a microservices and Kubernetes environment. From what everybody that I have spoken to, they end up saying, I wish I had started using Istio or some kind of service mesh sooner. I think it's a very important part of the journey. Nate, what are your thoughts?
I would say that when you have more, especially on the managed Kubernetes level, if you have more than, I'd say, 3 to 5 host-based routing configuration that you're using on a traditional ingress, you're going to want to consider Istio pretty quickly. That's really probably the best indicator on a broad level that I can provide.
Great. Oh, there's another one.
Yeah, the question is, does Ortelius have a dashboard? I understand per cluster view, Kiali can be used, but is there a higher level UI view? Yes, so Ortelius has a dashboard. And that dashboard is going to allow, again, it has a domain structure, so it allows you to publish microservices. And when you publish a microservice, you publish it with all of its deployment data, what Helm chart it needs to be used, what the SHA number is, what the git commit is to make that particular microservice a unique version. As Nate pointed out, as he was talking, you need to understand what version of a particular microservice that you're referring to. So it does that versioning. And then what it does is it allows application teams to consume those. And then we track through the CD process, we track the versions of the applications and their configurations. Think about it as a new BOM report or a new diff report or your impact analysis. So then Kiali is sitting there on the cluster and actually watching what's occurring. There is probably some good integration that Ortelius and Kiali could have between the two. Especially when it comes to things like deprecating, because deprecation seems to be a problem for a lot of microservice environments. It's good to know who's using a microservice. It's good to know what teams are using it and what version. I think we could probably be pulling some of that information back, but we're really just pulling it back from Istio.
Great. Well,
Okay,
thanks.
thank you.
Yeah, thanks Tracy and Nathan for a great presentation. Thank you everybody for joining us today. The webinar recording and slides will be online later. We look forward to seeing everybody for future CNCF webinars. Everybody have a great day. Thanks.
Thank you. Thank you, Nate.
Thank you.